Hi everyone, in this video let's look at probabilities of the solution when a variable declared as a random and if at all it's constrained. In this example we have a rand bit a and rand bit 1 down to 0b. The possible values for a are 0 or 1 and possible values of b are 1, 2, 3, 0, 1, 2, 3. Now the solution possible is like when a is 0, b can be 0, 1, 2, 3 and a is 1, b is 0, 1, 2, 3. The possible solutions are 8. When there are no constraints, the probability of getting each solution is equal. In that case we have 8 solutions and the probability is same for all the values, all the solutions. Now it will be 1 by 8. The probability of getting each solution is 1 by 8 in this example. Suppose let's look at another example where we have constrained the variables declared. Suppose we have constrained with the implication operator where a is equal to 0, then b should be equal to 0. Like that means like when a is 0, b must be 0, and when a is not 0, and reverse is not possible, as we discussed earlier in earlier videos. When a is 0, b should be 0. Now here let's look at, as we saw earlier, right, this is the solution space possible. And now if you see b, when a is 0, b can only be 0, it cannot be 1, 2, 3. Now if you see when a is 0, b cannot be 1, 2, 3. So these three set of values are not possible. So the probability of getting these values are 0, and these probabilities are merged to only this value. Now here in earlier table we saw that each value has 1 by 8. Now all the probabilities of these values will be merged to 1 by 2. Like 4 into 1 by 8 is 1 by 2. Like all this solution space will be merged to this one. For whenever there is a is 0, the only possible value is b. So the probability of getting this solution is 1 by 2, and the other solutions as earlier 1 by 8, 1 by 8, 1 by 8. Okay. Now in this example we added one more constraint where b is greater than 0. Now you see earlier here we are saying that b is equal to, when a is equal to 0, b must be equal to 0. Now we added one more constraint saying that b should be greater than 0. What does that mean is like a can be, here in this we are saying b must be 0 when a is equal to 0. What that means is like a can never be 0 with this change. Understood? Hope you understand. Here what I mean is like a cannot be 0 always. So when a is 0, b will be 0. But here I added one more constraint, b should be greater than 0. So a can never be 0. The probability of getting all these values, these values we never get. Okay, this set. Another set we never get is like this one, this set, because because of this constraint b should be greater than 0. This also won't happen. This whole five sets won't happen with this new constraint added. So we will be left with only 3 values, 3 sets, 1, 1, 1, 2 and 1, 3. So the probability of getting the value of each set is 1 by 3, 1 by 3, 1 by 3. That's all for this video.